All right, so let's take a look. Today we're going to be looking at law of sines and law of cosines. Now we learn our trigonometric ratios like sine, cosine, tangent, cosecant, and all those secant and cotangent. We learned those with a right triangle. Right? They work with a right triangle. With a right triangle, that means that one of my angles is 90 degrees. Now, what if neither of my angles are 90 degrees? So let's take a look at one triangle. I'm going to draw a triangle here, and let's assume none of them are 90 degrees. What we're going to be doing, first of all, let me label my angles. For angles, I'm going to use capital letters. For sides, because I'm also going to label sides, I'm going to use lowercase letters. So I have three angles. Let me label them A, B, C. Doesn't matter which way I label them. So I'm just going to go A, this is B, and this is C. Again, for angles, I'm going to use capital letters. Now for sides, I'm also going to label them A, B, C, but I'm going to use lowercase letters. Now the sides, because I already labeled the angles, the sides do matter how I label them. I see angle A is this corner. Side A is the side that is opposite from angle A. And remember, opposite in geometry means far away. This side right here is going to be side A. Right, the side that's between B and C. When I say side, I'm talking about the whole side. Notice how side A is opposite from angle A. Now let me label my side B. And just like I did with side A, side B is opposite from angle B. So I see angle B is this corner. So this is side B. When I say side, I'm talking about the whole side. And we're going to end up saying that this is side C, right? It's opposite from angle C. Okay, now that I use the labels, I'm going to use two formulas today. One we're going to call the law of sines, and the other one we're going to use the law of cosines. So two laws we're going to learn, and I'm going to use the same triangle, the same labels for both of them. So starting with the law of sines. So let me just write this down. Law of sines. So start with the law of sines. What this thing gives me is three fractions that are equal to each other. I only need to use two. And the two I'm going to be using are whatever information that I have. So let me give you the fractions first. It says side A over sine A is equal to side B over sine of angle B. And this is equal to side C over sine of angle C. So if I have information about angle A and side A, well, I will use the first fraction. If I have information about angle B or side B, use the second fraction. And obviously for side C, if you have information about side C or angle C, use the third fraction. Except from the three fractions, I'm only going to use two. I'm going to use the two fractions where I have some information about. Now, another thing I can do with the law of sines, I can flip my fractions. Or in mathematics, we call that reciprocal. But in English, we just say flip the fraction. So I can just say sine of A over side A is equal to sine of angle B over side B, which is equal to sine of angle C over side C. Now, which fraction am I going to use? I'm going to use the one where I have the unknown on top of the fraction. So if I'm solving for a side, use the top three fractions. If you're solving for an angle, use the bottom three fractions. Again, I want the unknown, whatever I'm solving for, I want it on top of the fraction. One reminder before we look at our examples, the three angles of a triangle add up to 180, right? You guys learned that back in the first semester. The three angles of a triangle equal to 180. So if I'm given two angles, I can solve for the third angle. So let's take a look at question number 9. It says, find each measurement indicated. Round your answer to the nearest tenth. Remember, tenth, I know it's a decimal, but it sounds like 10, which is a 1 with 1 0. So the nearest tenth is 1 decimal place. If I said hundredth, sometimes I use hundredth, sounds like 100, which is a 1 with 2 zeros, so that's 2 decimal places. So this one is 1 decimal place. So do expect your answers to be decimals, and we're going to round it to the nearest tenth. So I look at my angles first. I see my triangles. I'm given 2 angles, 122 and 27. If I add those 2 angles, 122 plus 27, if I add those 2 angles, I get 149. Now I'm going to subtract that from 180. And the reason why I'm doing this is because I know all 3 angles add up to 180. So let me subtract that from 180, and that gives me 31. Now, the reason why I did this is because I can find out that angle B is 31 degrees. I might use angle B, I might not, but I'm just going to have it just in case. Okay, so let's take a look. BC, right? 2 letters, so that means a side. If I look at the side, BC is this side, which I'm going to call side A, because notice how it is opposite from angle A. So I have to solve for side A. So I'm just going to remember one of the fractions that I gave you was side A over sine A. I'm going to use that. I'm solving for A. As a matter of fact, I know what angle A is, but right now I'm just going to write the fraction as it was given on the formula. Then I see what other side do I know? And in this case, I know side B, right? It says side B 17 degrees. So right now, I'm going to call that side B. Then I'm going to write this as side B over sine of angle B. Again, those are the fractions that I'm going to use. Let me replace my letters like A or B. Let me replace my letters for the information that I have. What I mean with that is, I don't know what side A is. Obviously, that's what I'm solving for. I'm going to write at the bottom sine of 27 degrees. This is equal to 17 over sine of 31. Good thing I solved for angle B when I use it. I know in a fraction to get rid of the denominator, I'm looking at my fraction on the left, to get rid of the denominator, I just multiply both sides by the denominator. So let me multiply the left side and the right side. Let me multiply each by sine of 27. So this cancel out. Matter of fact, this is a fraction. In a fraction, when we're multiplying by sine of 27 in this case. When we multiply, we write it on the top. So notice how my sine of 27, I wrote it on the top. When we're dividing, we put it at the bottom. Okay, so here on the left side, I have A by itself, which is what I'm solving, so that's good. On the right side, I have 17 times sine of 27 divided by sine of 31. Good thing we have a calculator. We're going to type that in. I'm going to show you guys how to do it using the calculator from Canvas. I encourage you guys to use that calculator. You can use your own. If you have a TI-30X, you type it in very similar to how you type it in the calculator from Canvas. Now, if you're going to be using the calculator from your phone, especially an iPhone, you're going to be using those calculators. iPhone types it in different. So instead of sine of 27, iPhone says 27 sine. So be very, very careful which calculator you use. I encourage you guys to use the one from Canvas. I'm going to show you guys using the one from Canvas so you guys can follow along. Let's take a look. Let me open my calculator. As a reminder, as I mentioned before in previous lectures, when I first opened my calculator, here it says RAD, which is radians. I'm not doing radians, right? 6.28 radians is a whole circle. Now 6.28 degrees, not even close to being a whole circle. So make sure you don't have radians, you have degrees. So switch it to degrees. And then I'm just gonna type in what I had. I remember on top of my fraction, I had 17 times, notice I'm typing it, 17 times sine of 27 Don't forget to close your parentheses after typing that in. So notice I typed in everything I had on top of the fraction. 17 times sine of 27. And then I'm gonna use divide, because a fraction is division, and then everything I had after the fraction. So sine of 31, close your parentheses, and then press enter. I know I asked you guys to round it to the nearest tenth, which I said 1 decimal place. For the moment, let me write 2 decimal places. Let me write 2 decimal places. So according to calculator, says 14.98. Let me come back to my work here. So I'm going to say A is 14.98. I'm going to write 2 decimal places because I might be able to round. When I say rounding, I look at the second decimal place. If it is big enough, and big enough is 5 or more. Right now it's an 8, so in this case it is big enough. When it is big enough, it's going to push the previous number up. If it's too small means 4 or less, just ignore the second decimal number. So here, if my second decimal place was too small, my answer is 14.9. But because it is big, my 8 is going to push the 9 over. Now do me a favor, 14.9, do not call it 14.10. 14.10 is the same thing as 14.1. So instead of rounding it up, you rounded it way down. So do not call it 14.10. Now, because my 9 is the highest digit there is, right? It cannot be pushed up. This 9 ends up pushing this previous number. So pushes the 4 up. So it's going to be 15. So A in this case is going to be 15. Remember, the 8 pushed the 9, but the 9 was the biggest number there was. So the 9 ended pushing the next number, which is a 4. So my answer is 15. If you write 15 or you write 15.0, because you want to write as decimal, either answer is correct. So if just 15, the 0.0 we can ignore. So you write either just 15 or 15.0. It's up to you. All right, let's take a look at question number 10. We're going to take a look at another example. I see that I'm given 2 angles. So let me solve for the third angle. I see the 2 angles given are 40 and 95. And if I add those two, 40 plus 95 is 135. So let me write it here at the side, 135. Let me subtract that from 180 because I want to know how big is the third angle. It says 45 degrees. So I'm going to say, all right, if this third angle is 45 degrees. Again, I might use it, I might not. Here, I'm solving for side AB. If you connect corners A and B, I'm looking at this side. Is the one side that is opposite from angle C, so I'm going to call that side C. Because I'm solving for side C, one of my fractions, I'm going to write C over sine of angle C. And then I look around and ask myself, do I know any other side? And in this case, I know side A. Side A is 22 degrees. So I'm going to use side A over sine of A. And then replace the values that we know. Side C, I have no idea what it is. That's what I'm solving for. So I'm just going to call it C over sine of 40 degrees is equal to 22 over sine of 45 degrees. So matter of fact, here on the right side, let me make this a big fraction. Let me extend the bar. Looking at the left side, to leave C by itself, let me multiply by sine of 40. So here I'm going to multiply by sine of 40. On the right side as well, let me multiply by sine of 40. Notice how multiplication, I said we're going to multiply, so I wrote it on top of the fraction. So sine 40s cancel out. So I get C equals, and then I'm just going to go 22 times sine of 40 divided by sine of 45. Let me type that in. So let me grab my calculator out, and I'm just going to go 22 times sine of 40 divided by sine of 45. According to my calculators, 19.99. All right, let me come back to my work. So 19.99. The second decimal number is big enough, so it's going to push this previous number. The 9 is the highest it can be, so it ends up pushing the previous number, which is also a 9. So that 9 pushes this other number. And in this case, my answer will be 20.0 or just 20. Remember, the 0.0 can be ignored. So 20.0 or just 20. All right, so that's not that bad. How about if we have to solve for an angle? Here for question number 11, it says find the measurement of angle B. If I had two angles, it would be easy, right? Because I just add them up and then you subtract it from 180. But here I only have one angle, which is angle C. Happens to be 90 degrees. So what I'm going to do, let me label what I have. I have side B, right? Side B is 32 degrees. I have side C, which is 33 degrees, and I'm solving for angle B. So I'm gonna write this as sine of angle B over side of B. Remember, that was our fractions that we learned, and I said, whatever I'm solving for, I'm gonna put it on the top. I'm solving for angle B, so let me put sine of angle B on the top. Then I have no information about A or angle A, so I'm not going to use that. Instead, I'm going to use sine of angle C over side C. I have the angle C and I have the side C. Let me replace the values that I have. So I'm going to write sine of angle B over 32 is equal to sine of 90 over 33. Let me make my fraction here to write a little longer, the bar. Let me multiply both sides by 32 because I want to get rid of the fraction on the left. So multiply by 32. So here, let me multiply this by 32 as well. So I get that sine of B is equal to sine of 90 times 32 divided by 33. Let me grab my calculator for that. So I'm just going to go sine 90 degrees, close parentheses, times 32 divided by 33. According to my calculator, is that 0.96969696 on and on. Okay, for right now, let me just write here. I'm gonna go 0.9696. I know on instructions it says round your answers to the nearest tenth. I'm not quite done yet, so I'm gonna use 4 decimal places. I'm gonna round the answer, but I'm not quite done yet. So again, I'm just gonna do this. I know we learned on Monday, how to solve for an angle. If I know the sine of B equals 0.9696, I'm gonna say angle B is equal to the sine inverse of 0.9696. Remember, we learned the inverse. Some people call it arc sine. So let me come back to my calculator. Let me erase this. I see sine, but I don't see sine inverse. Remember, I mentioned about this little key that says second. Press it. So now I see sine inverse. My calculator says a sine because it calls it arc sine. And then I'm just going to type in 0.9696. Be careful not to round the work, because if I was to round this, it's 1 and it will give me a whole different answer. Okay, so arc sine of 0.9696, I press equal, and it says 75.83. Okay, so let me come back here. 75.83. My second decimal place is a 3, which is too small. So I'm just going to ignore this. And my answer is going to be 75.8. So my angle B, 75.8 degrees. Let's take a look at angle C. Question number 12. I have side A, I have side C, and I have angle A. Because I'm solving for measurement of angle C, I have to use sine of angle C over side C. And then, because I have information about angle A, I'm going to write sine of angle A over side A. Let me replace the values that I know. So I'm going to write sine of angle C over 16 is equal to sine of 119 over 32. To leave sine of C by itself, have to multiply both sides by 16. Let me extend this fraction. So multiply this by 16, multiply here by 16. Remember, multiplications, as a reminder, I always write it on top of the fraction. So I have that sine of angle C is equal to, let me multiply that out. Let me grab my calculator. I need sine, not sine inverse. So let me press second again. So I'm going to go sine of 119 times 16 divided by 32. And it says 0.4373. I'm using 4 decimal places. So 0.4373. Now sine inverse, I'm going to use that for angle C. I'm going to use sine inverse of 0.4373. And that gives me, let me come back to my calculator. I need sine inverse. I got to go second, clear this out. So sine inverse of 0.4373. Let me get this right. It says 25.93. Okay. So my angle C is 25.93 degrees. I look at the second decimal number. This case is a 3. It is too small, so I'm going to ignore that. Remember, too small is 4 or less. So my answer would be 25.9. The law of sines is not that hard, right? And I'm always going to use the law of sines whenever I know a side and the opposite angle. Notice how for question number 9, I knew angle B and side B. Question number 10, I knew side A and angle A. So every time you have a side and the opposite angle, I recommend you guys use law of sines. Now, law of sines cannot always be used. Looking at question number 13, the only angle that I have is angle B, but I have no information about side B. Okay, so law of sines cannot be used always. So we created this thing that we called law of cosines. Okay, so let me write this thing down. Law of cosines. Now I'm gonna use ABC as inside ABC or angles ABC, the same way we use them for law of sines. So let me remind you guys of the triangle that I use. That's the triangle I'm gonna be using. Remember, angle A is opposite from side A, angle B is opposite from side B, and angle C is opposite from side C. Now the law of cosine, there's gonna be 3 laws. Okay, it looks very similar to Pythagorean theorem. We know Pythagorean theorem. So this is going to be looking very, very similar. one of my formulas for the law of cosine is going to be c squared, and I mean side c. So actually, let me make that a little smaller. So side c, so c squared is equal to a squared plus b squared. So it kind of looks like Pythagorean theorem, but then at this part I'm going to add a minus 2 times a times b times cosine of angle C. Now, for the right triangles, when we learn Pythagorean theorem, technically we had this last part. I just didn't mention it because cosine of 90 degrees is 0. So that cancel all this part at the end. The minus 2ab times cosine of C, because cosine of 90 is 0, they cancel everything out. Okay, so that's how we have it. Another formula, because I said we're going to have 3 formulas. Another formula we're going to have is a squared. So side a squared is equal to b squared plus c squared minus 2 times b times c times cosine of angle A. And the third formula we're going to have is b squared is equal to a squared plus c squared minus 2 times a times c times cosine of angle B. Now, the way I'm going to know which one to use, I'm going to have to use one of the 3. The way I'm going to know which one to use is depending on the angle given. Notice how each of my formulas end with a cosine of angle C or cosine of angle A, cosine of angle B. If I'm given angle C, use the first formula. If I'm given angle A, use the second formula. If I'm given angle B, use this third one. So this is how I'm gonna know which one to use. Keep in mind I said angle, whatever angle you're given. Doesn't matter which one I'm solving for, the angle that I'm given, okay? So let's take a look, question number 13. I'm given angle B. Just to remind you guys of the formula, is gonna be b squared is equal to a squared plus c squared minus 2 times a times c times cosine of angle B. And I'm looking for the side because it's find AC, which is this side. I'm looking for side B. Okay. I don't know what B is, right? So I'm just going to write this as B squared is equal to, I know 27 is side C, and I know 15 is side A. Okay, so I'm just going to go 15 squared plus 27 squared minus 2 times 15 times 27 times cosine of 103. I know it's kind of lengthy. Good thing we have a calculator. The calculator is going to do all the work. Let me zoom in. It's zoomed out by itself, so let me zoom back in. So I'm going to type all that in. So let me grab my calculator. I need cosine, not cosine inverse, so I switched it back to cosine. So let me write this thing out. I'm going to go 15 squared. Notice how I did the carry to 15 squared plus 27 squared minus 2 times 15 times 27 times cosine of 103. Close parentheses. So I make sure that I typed it correctly. 15 squared plus 27 squared minus 2 times 15 times 27 times cosine of 103. Press equal. So I get 1,136. I get 1,136 let's go 2103. I'm gonna go 4 decimal places. So let me come back to my work here. You guys might be like, well, this is pretty lengthy because I'm not quite done yet. So b squared is 1136.2103. I'm using 4 decimal places because I'm not quite done yet. I'm solving for b, not b squared. And we talked before how to get rid of an exponent. Remember I said addition, subtraction, undo each other, multiplication, division, undo each other. So the way we undo an exponent is with a radical. This case is a b squared, so I'm gonna do the square root. So that's gonna give me b, which is what I'm solving for. Then I have to do the square root of this number. Let me come back to my calculator. Let me clear this out. Square root is right here. You guys see it? It even says SQRT. So square root of 1136.2103. And it says 33.70. Okay. Let me come back to my work here. 33.70. Right, I write 2 decimal numbers for my answer. I take a look at the second decimal number. It's a 0, so it's too small. And again, too small means 4 or less. So my answer would be 33.7. Okay, makes sense. Let's take a look at number 14. I'm solving for side AC, which sometimes we call side B. I know this is the biggest side. One of the sides is 10, the other one is 12. So I'm expecting a number more than 12, right? I can see B is bigger than 12. So I'm expecting something more than 12. I have side C, I have side A, and I have angle B. Because I'm given angle B, the formula I'm going to use will be B squared is equal to A squared plus C squared minus 2 times A times C times cosine of angle B. Because I'm given angle B, I'm going to use the one that finishes with cosine of angle B. Let me replace the values that I know. So B squared, it's equal to 10 squared plus 12 squared minus 2 times 10 times 12 times cosine of 134. Let me grab my calculator to be able to type that in. So I'm going to go 10 squared plus 12 squared minus 2 times 10 times 12 times cosine of 134. Close my parentheses. And it gives me 410.7180. Come back here. So I'm going to say that B squared is equal to 410.7180. Okay, let me come back to my calculator because I have to get B, not B squared. And remember, I said to cancel an exponent, I'm going to use a radical. In this case, a square root. So that's going to give me B equals. So I'm going to come back here. I'm going to do the square root of 410.7180. I'll type in the last 0. Close parentheses equals 20.26. Okay. So 20.26. the last number, the second decimal number is big enough, right? A 6 is big enough. So pushes this 2 over. So it's going to be 20.3. Now the 0.3, I cannot ignore this. So I have to write in 20.3. Okay. So solving for a side was not that bad. Now let's solve for an angle. Now it's a heads up. This is where you guys are going to be working a little bit more. When you're solving for an angle, I have no sides, so I cannot use the law of sines just yet. When I'm solving for an angle, I have to use the law of cosine. I don't have an angle here, don't have an angle given, but I'm solving for angle A. So I'm going to use the formula that finishes with angle A. So I'm going to write A squared is equal to B squared plus C squared minus 2 times B times C times cosine of angle A. Okay, before I type in the numbers that I know, let me create a formula here. Let me do something. My B squared and my C squared, let me move it to the left. So let me call this A squared minus B squared minus C squared is equal to negative 2 times B times C times cosine of angle A. I'm really trying to have angle A by itself. That's really what I'm trying to do. Okay, so the left side is all multiplication. The way I undo multiplication is by dividing. So let me divide both sides by negative 2BC. So negative 2 times B times C. Because that way the negative, the 2, the B, and the C cancel out. So I have that A squared minus B squared minus C squared all divided by a negative 2 times B times C. It's equal to cosine of A. The left side is all numerical, right? I can replace the values that I know. I know side A is 12. I know side B is 16. And I know side C is 13. So let me replace this as 12 squared minus 16 squared minus 13 squared. So matter of fact, let me put the top in parentheses, the top of my fraction. So when I type it in, I tell myself that's a parentheses. So I gotta work that first. And then whatever I get, I'm gonna divide this by a negative 2 times 16 times 13. And that's gonna give me cosine of angle A. Okay, so let me grab my calculator out. Let me worry about the top of the fraction first. Let me clear this out. Top of the fraction, I had 12 squared minus 16 squared minus 13 squared. And I press equal because I said I wanted to worry about that first. Okay, it gave me a negative 281. It's fine because at the bottom I have a negative, so I'm pretty sure the negatives are going to cancel out. So I'm going to go divided by. Notice I did the top of the fraction first. Divided by. Now for the bottom, I want the calculator to just do the bottom first, combine it. Now, be very careful now. Here, I'm going to use a negative 2 at the bottom. So remember, at the bottom, I have a negative 2 times 16 times 13. Do not use the minus sign. Instead, negative 2. Make sure you use your negative sign. So be careful. Don't use the minus, use the negative. So at the bottom, I have to go negative 2 times 16 times 13. close parentheses. So remembered, I did the top first. I'm gonna go divided by. Notice how the bottom I wrote it inside a parentheses. Remember we had to do groups before we do division. Okay, so then I press equal, and it tells me 0.6754. Okay, let me come back to my work here. So I have that 0.6754. It's equal to cosine of A. And I'm solving for angle A, not cosine of A. So I'm going to say that cosine inverse of 0.6754, it's equal to angle A. Okay, so let me come back to my calculator. Clear this out. I need cosine inverse, so gotta go second cosine. So cosine inverse of 0.6754. It says 47.51. Okay. 47.51. The one is too small, right? The second decimal place is too small. I'm just going to ignore this. So 47.5. Cool. Let's take a look at one last example. Question number 16. I have side A is 20, side B is 12, and side C is 28. And I'm solving for angle C. It says find the measurement of angle C. So from the formulas that I have, I'm going to use the one that finishes with angle C. So let me write this as C squared is equal to A squared plus B squared minus 2 times A times B times cosine of angle C. Again, I want to type in the numbers at the end if possible. Let me play with my formula. My A squared, my B squared, let me move it to the left side. So I have C squared minus A squared minus B squared is equal to negative 2 times A times B times cosine of angle C. Kind of like I did in the previous example, let me divide both sides by negative 2AB, because that way the negative, the 2, the A, and the B cancel out. So I have that C squared minus A squared minus B squared divided by negative 2AB is equal to cosine C. Let me replace the values that I know. So 28 squared minus 20 squared minus 12 squared over negative 2 times 20 times 12. And all this is going to equal to cosine of angle C. Okay, so my calculator here. I'm going to use cosine, so I'm going to get that ready. Let me clear this out. So I have 28 squared minus 20 squared minus 12 squared. I even press equal. I want to worry about the top first. So let me see this really quick here. Okay, so the top gave me 240. There's a negative at the bottom. Okay, so I guess I'm gonna have to deal with negatives. Divided by, at the bottom I have a negative 2. Let me open parentheses. Make sure you use the negative 2 times 20 times 12. And it gives me negative 0.5. Okay. Let me come back here. So I have that negative 0.5. It's equal to cosine of angle C. Angles are positive, but cosine of angles can be negative. So it's fine. We have a negative. So for me to solve for angle C, I'm going to use cosine inverse. So cosine inverse of a negative 0.5 is going to equal to angle C. Okay, let me find out what that is. Don't forget the negative sign when you type it in. So let me clear this out. I need second cosine inverse. Don't forget the negative sign of 0.5 equals 120. Cool. So angle C is equal to 120 degrees. If you have any questions, make sure you contact me.